Hi, my name is Debbie, and this is my lab report for the second lab in Physics 2212, Lines of Charge. First, I just want to revisit the fundamental principles that we used in the first lab as well as in this lab. We used Coulomb's law, which states that opposite charges attract one another, whereas like charges repel one another. We also used the definition and equations for electric fields and electric forces caused by these fields, which states that an electric field is proportional to the charge over the distance squared, and the electric force is equal to electric field times the charge on the second object involved. Now, again, in this lab, we determined the charge on a piece of tape that was caused by the motion of pulling apart two pieces of tape. We did this motion in lab 1, and so I utilized my results from lab 1 in this lab as well. We balanced the gravitational and electric forces when we observed a tape floating in order to calculate electric force, and then we also utilized glow script in order to estimate the amount of charge on a piece of tape necessary to float one tape over the other. However, in this lab, we did not treat tape as a point charge as we did in lab 1. Instead, we spread the charge evenly across the length of tape, broke the tape up into small sections, and used integration methods in order to determine the charge over the piece of tape. Again, in lab 1, we pulled apart a piece of tape and observed the charge caused by this motion. We recorded how the tape interacted with each object in each situation when we held it near a neutral object, a charged object, and a positively or negatively charged object. We also recorded the floating tape model, which is more important in this lab. We attached one charged piece of tape to two textbooks to suspend it, and then we held the other tape near the suspended piece of tape and recorded the distance of the tape floated. I will show you the distance the tape floated and all of the experimental data from lab 1 in a later slide. Then for lab 2, we utilized the data found in lab 1, which was summarized on the following slide. We then produced a computational model of two charged tapes exerting an electric force on each other in glow script, and we used this model to estimate the total amount of charge on a piece of tape. So we spread the charge evenly across a piece of tape, split it into n number of pieces where the charge on each piece was equal to the total charge of the tape over the number of pieces we split the tape into, and we use integration in glow script to determine the charge across the entire piece of tape. Assumptions that we made in this lab are air resistance on the moving tape was ignored, so it's equal to 0. The net force acting on the piece of tape was just electric force due to the other piece of tape and the force of gravity. We also treated each tape as if it held the same amount of charge, and we spread charge evenly across the length of the entire tape. Now, my experimental model in lab 1 resulted in these following data points. So the tape length was approximately 0.192 meters, and the floating distance was 0.002 meters. And the calculated electric charge, when I assumed that the tape acted as a point charge, I calculated to be 9.19 e to the negative 10 coulombs. Now, this is just a portion of the glow script code. I will link the rest of it down below, but I just wanted to highlight, as you can see here, I broke each piece of tape into multiple pieces and then iterated through calculating the electric field and the electric force on each small piece, and then summed them up at the end in order to calculate the total electric field and force and charge. Here are some of my results from glow script. So I was able to actually change the amount of pieces I broke my tape up into and see how this changed my results. As you can see, the magnitude of the electric force calculated when I broke the tape up into 10 pieces was close to 1.8 e to the negative 4 newtons, whereas the magnitude of the electric force calculated when I broke it up into 50 pieces was closer to 4.6 times e to the negative 5 newtons, so much smaller. This leads us to the additional questions. What if we had modeled each tape as a single point charge? Well, we did this in lab 1, and as you can see at the bottom, the data I observed when I treated each tape as a point charge was that the magnitude of electric force was about 0.0019 newtons, and the magnitude of electric charge across a piece of tape was about 9.1 e to the negative 10 coulombs. Now, as you can see, as I increased how many pieces I broke my tape into, the results got much closer to 0.000038 newtons of force and 4.45 e to the negative 8 coulombs. Now, why is this so? Why do these estimates differ? Which value is more likely to be closer to the real value, and why? Well, assuming that charge is distributed equally across the tape and breaking up the tape into small pieces is actually much more realistic to how the charges act in real life. They do not act as a point charge across a large object. So this more realistic model yields more realistic results, and as we increase the amount of pieces we break the tape into, our results become much closer and more accurate to the real results. Thank you.